Oh no! Started. All right, let's see. Let's see how long this can last here. No questions on homework. You guys are doing great. I've gotten a decent amount of chapter 7 stuff. I'm grading it as it comes in. Um, so hopefully, and did anybody notice I put the solutions up for the practice quiz? You can say no. Let's see. So practice quiz stuff, practice quiz 6, quiz 6 solutions video is up there. So you can take a look there. All right, somebody did. Yay! So you can watch it, you can not watch it, you can look at that practice quiz, you can not look at it. Totally up to you what you want to do with that or not. I love it. All right. And I guess, of course, the quiz is on Monday, so it's going to be after class. So, oh, it's telling me my internet connection is unstable. I know that. I know that. I was going to take personal offense. I thought I was talking about me. I know I am unstable also. So no other questions from homework? You guys are good on the homework? Everything's going great?
I mean, I don't know about good, but I can do the work, I think.
All right.
uh,
I
right
mean,
now in 3-4, there's just a few that I'm like struggling on.
3-4?
Or sorry, 7-4.
7-4. Okay.
See how much I'm struggling on? I'm in the wrong chapter.
I was worried, but I was appreciating the honesty if that was true. But let's see. So you're struggling with some in 7-4? Anything specific?
um, 41.
All right, let's see.
kind of gross looking, but and
Okay.
also 42.
Yeah, so if sine t is this and cosine t is that. Oh, now, all right. I want you to realize, all right, let me see, how can I say this? Well, let's just say it directly. This is a remarkably easy question. And I don't say that to make you feel bad, Austin, because it looks like, holy shit, right? I mean, they don't give me a picture to work with. I don't know what the angle is. They give me a couple things. What the hell? But what is secant defined to be fundamentally?
The inverse of, not the inverse,
The reciprocal?
the reciprocal. Yeah, that's it.
Uh,
Of sine.
no.
No, of cosine. Sorry. S
S
is
goes with C. C
yeah.
goes with S. I like it. So since you know cosine, you know secant. Since you know sine, you know cosecant. And of course, tangent is just
The two halves swapped pretty much.
2/2. I don't understand. So it's
No, yeah,
tangent
sorry.
is sine over cosine.
Yeah.
Cotangent is 1 over that, or it's cosine over sine. Is that cool? So 41
Hmm.
is actually really nice. It's very little work. It's just really just a question about, do you remember what the reciprocal functions are?
Yeah, yeah.
Okay.
Like, yeah, I'm working through it. I I think I'm doing it right. Like based on like what you've told me so far, like I'm not off. It's just taking me a little while. I'm memorizing is what it is. Yeah.
Uh-oh.
I can hear him.
There we are. Am I back?
I think you are. Your connection's red, but I think you're here.
My connection is red. All right. Hold on. Oh yeah, it's a little worse than it was. That's exciting. No, I stopped sharing my screen on purpose.
I like Kurt's comment. He says, he left us. He left us. It's like Jurassic Park. I knew it. Rio, you're the new teacher.
I think so.
Hey, you all stayed. That was exciting. Oh my gosh. That
There was some
quite-
debate.
First, I was thinking to myself, oh, the people that I could see are just playing with me. like I thought Rio was being very, very still. There you go. Yeah, you're the only one I could see. So when you go still, I'm like, oh shit, I'm gone. Here, let me
You
highlight.
gotta puppeteer it.
What's that?
I just picture Rio just like puppeteering. I was like, put your arms up and stand still, just like you're locked in place.
All right, guys. All right. Let's see. All right. Let me double check things. All right. I'm going to try to do very little tonight unless it's suddenly come back somehow. Let's see. No, it's about as bad as it was. Okay. All right. If that happens again, I'm basically going to have to cut class short. Okay, let's see. So let me come back. Are there any other questions? I think I can still share my screen. And again, I apologize for this. I'm kind of surprised this doesn't happen more often in all the time I've been teaching online. Anything else from homework stuff, guys? Did we finish that? And Austin, you see that 42 is basically the same as 41?
Yes, they are.
Okay.
Yeah, I see it.
Cool.
That definitely like directed my thought process, so it makes it quicker.
42 is more evil because it has more specific stuff and it makes you feel like you're supposed to do more, but it's instead of T that put 40, who cares? It's the same idea. I like it.
Yeah.
Okay. All right. So what I want to try to do, let's see how far we can get with this. And let's see, no, I don't like it over here. All right. Can you guys see the whiteboard thing? Oh shit. No, you can't. Let me try this again. How do we get you to start up again? No, I don't want that down there. Okay. Let me try this again. All right. There we go. Now you can see the whiteboard, right?
Yes.
Okay, now. So real quick, if you weren't here last time, ooh, it's all purple. I love it. If you weren't here last time, we actually talked about, we created the graph of sine. And we did it the old-fashioned way. Whenever you hit a function and you don't want to know what it looks like, you make an XY table. That's exactly what we did. We just made an XY table. I promised you that I would tell you the most important points to use. And really, the most important points to use are from 0 to 2 pi. Now what happens? What's special about 2 pi? Do we know enough about what's going on here to know what's special about 0 to 2 pi?
It's a period.
Okay, but let's not use that word yet because that's actually how we define that word
One
is
full circle.
one full circle, and it means that sine has gone through all of its possible orientations, right? So and that only makes sense. It's just going to kind of repeat itself starting right there. So it goes from 0 to 2 pi. So what we do, the word periodic, what does it mean? What's the word periodic? Like, have you guys ever heard the word periodical? Periodical? Anybody ever heard that word?
Yeah, I've heard it a few times at least.
You know what that is? It's like an old-timey word for what? Do you know?
It's like every so often, like, or like in
I want to spell
repetition.
finally. Sorry, old-timey. Okay. So periodical. If something happens periodically, it happens at some repeating. It kind of repeats at some interval of time. I love it. Periodical is what they used to call magazines. Get the periodical. And that just meant it was given to you every now and again, which meant it had a period to it. There was a certain interval of time over which would happen again. It would come again. It would come again. That's periodical. So we have functions that are periodic. We have periodic functions, meaning that they just repeat their outputs on regular intervals. There's some period to their outputs. So sine, of course, goes through like this. These are the anchor points. These are kind of like our main points for sine. And pretend as if that's a good, pretend like I did that good. All right, let's see. Here we go. All right, and then it's just going to keep going forever that way. It's going to keep going forever that way. But from 0 to 2 pi, I keep motioning to the camera as if you could see me. I'm sorry, you can't see me, shit. 0 to 2 pi captures everything that it does. It kind of is like the image. So if I cut 0 to 2 pi, I could just copy and paste it in both directions forever, correct?
Yeah, seems
Okay.
logical.
Does that make sense to everybody? So we call this, so this is one period. Get in there. Oh man, what happened to you? Oh, I can't go up that far. Okay, good to know. I haven't used this thing ever. So that's one period. Okay. And of course for cosine, I kind of like, well, anyway, we'll do the same thing from 0 to 2 pi. But what does cosine start at? What's cosine at 0 degrees? Or 0 radians? Yeah, it starts at the highest point. So it just takes this point and moves it back 90 degrees. So it's like this function shifted back 90. And you should inherently kind of have a feel for that sine and cosine are off by 90 degrees from each other. So it's nice to see the graphs doing the same thing, right? So this has got the same scale. So it goes like that, bam, 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 bam. So we got this part of it. All right, so if you, holy crap, Jeff. All right, poor little thing. This should be going down like that, gather. All right. So see, that's basically the cosine piece right there, right? Just if I just take this and shift it back, bam, there's cosine. I personally kind of like to look at cosine with 0 in the middle and go back here in this way, because then it looks like an octopus, right? Sort of. Anyway, don't worry about that. That's bam, bam. Okay. All right. So those are the basic sine and cosine graphs. Okay, so just like we are supposed to know stuff like square root of x, right? Where you have 0, 0, 1, 1, and 4, 2. I don't mean to put that line in there. Oh, well, 2. You know, you have, or you have e to the x, or, 2 to the x or something. I keep motioning to the camera. You can't see me. Okay. Is everybody understanding what's happening? I really need you to let me know if you understand this, because I still feel we have shifted functions a lot. I have discussed transformations of functions a lot with you, but I have a feeling that a lot of you still don't quite understand it. But if I have a graph like y equals 2 to the x, can somebody tell me what my anchor points are? What are some good anchor points to use for this if I was going to have to shift it? Like if I had to do this.
0.
What about 0? That's not a point.
Oh, it will. 0, 1 is a point.
There you go. All right. So 0, 1 is a good anchor point. What else?
1, 2.
1, 2. I like it. And on my scale there, what's another good one?
On that scale, I was gonna say -1 and 1/2.
Good. -1, 1/2. Those are the 3 really good. And then of course you got your asymptote there. Those are the 3 really good anchor points. And then you can just shift the points around and then draw the shape back on. So guess what we're gonna do with these crazy ass things? we're gonna shift them around and then put the shape back on. And this is a awesomely easy shape. Is everybody kind of with me? A little bit, no. All right, so let's see if I can, I'm gonna clear all this away. You guys ready? Here it goes. All this is going away, okay. So let's look at something like, oh yeah, I wanted to check this, hold on, sorry. How's my Wi-Fi doing? Holy shit, it's worse. Okay, fine, stop. I don't want to see it. All right. All right, so let's look at something very simple. What would this do? In fact, I mean, what is a number out front like this? What does a multiplier like this do to any function? What kind of shift or transformation would that be?
Yeah, vertical stretch.
Yeah, it would be a stretch. And again, I don't care that much about the terminology, but if originally is y equals sine x, dadgummit, and I put a 2 in front, then isn't this just making all the outputs twice as big as they used to be? Just to strip away all the stupid terminology. I'm just making all the outputs, which used to be sine x, I'm just making them twice as big as they used to be. So of course it's going to stretch it in the vertical direction if you want to get all technical. Okay, I just don't want the words to make everything seem as if it's difficult, and that's not true. So how am I going to do this? Well, to be honest, we don't necessarily have to draw the base function for this, right? So normally what would I put here and here? What would I put up here normally? If I was going to draw this guy, what would I put here?
1.
1, because that's the maximum. What am I gonna put there now?
2.
Holy shit, right? Because all my outputs are now 2 bigger than they used to be. And then I'm just going to draw the sine shape, but instead of stopping at 1, I'm just gonna go to 2. So it's gonna start at 0, 0, it's gonna go to 2, it's gonna go down to 0, it's gonna come back down to -2. And let me make sure, is everybody cool with those? I've done those points several times now. Are you guys all decently cool with these points? Right, I know at 0 degrees, sine is 0. I know it reaches its maximum at pi/2, which is 90 degrees, right? Then when it comes back to the x-axis, it starts to decrease until it's 0 again at the x-axis. And then of course, once you are past that, you're in the territory where sine is negative because my y value is negative. Okay, if you just try to connect with the idea, it makes the specific things you have to do easier, right? So this picture makes complete sense based on what sine measures. Sine measures the length of the y side. So it's going to do exactly like this. All right, I have no idea if that made sense. Let me see, I'm tired of purple. Let's make it, let's go to this color.
So on that one, all that really changed was the scale of y.
Yeah, exactly. So
Right.
if the only thing that changes is the vertical stretch, if the only thing that happens is a vertical stretch, that's really kick-ass. You just have to do exactly what you just said. You just have to change the scale and the picture stays the same. That's awesome. So this thing is officially called the amplitude. Now, the mistake people make, and does that make sense? I mean, if I saw this sine function for some music somebody's playing, and then somebody comes in and the sine function goes to this, what does that mean about the other person's sound? The other person's, what does that mean?
It's more noisy or it's amplified?
Louder. Yeah, it's louder. It's amplified. Holy shit. So that's the amplitude. I like it. So a vertical shift of sine and cosine, we actually call that a change in the amplitude. All right, I like it. And one big mistake people make, how far does this actually range? How far do the outputs of this result range?
4.
This one?
Yeah, how far do the answers range? Does that make any sense? I mean,
2.
-2 to 2,
-2 to 2, so how far is that?
4.
4. Does that have anything to do with the amplitude? 4, not really, right? So the mistake people make is the amplitude is measured with respect to the 0 line. Does that make sense? The 0 line? You guys at all with me?
Yeah, that
The
makes
line-
sense.
It's the line around which the function seems to be oscillating, right? So of course, the next thing I'm going to look at is what happens if I do this.
Shift up.
Yeah, it shifts up 1. So the line around which it oscillates shifts up 1. So let's see. So this is one where you might want to start with the normal stuff. Way to give yourself enough room, Joe. All right, let me start over again, guys. Hold on. Blah, 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 blah. All right. There you go, buddy. Let's see what we can do here. So we got my pi over 2, my pi, my 3 pi over 2, and my 2 pi. That kind of captures the trip around the circle, right? Around the unit circle. So if I graph the base function, it's going to be 0, 0, pi over 2, 1, pi 0, 3 pi over 2, negative 1, because that's equivalent to being down here, right? And then 2 pi is when I get back to 0. So this is like the base, what I call the base function. Yeehaw! All right. So then, like I think Rio said, I can't remember, I'm just going to take that, every point, just lift it up by 1. So I'm going to take that point, lift it up 1. Where's the midline going to go?
It's going to become 1.
Yeah, it's going to become 1. Aw. So it's not quite the same thing, but remember when we did exponential functions, one thing you had to do was figure out what the hell happened to the asymptote. Where does it end up? This is not an asymptote, but it shifts just like an asymptote would, right? So there would be a midline right here. That's going to be where it seems to be oscillating around. All right, I like it. So I'll take this point and shift it up 1. Am I recording, by the way? Wasn't really
Yeah.
keep
Yeah.
neat. I don't know what Zoom is going to do with all this recording rouge. All right, so then that went up by 1. So then this is going to go up by. Why did I do that? All right, you guys have to excuse me. Do you see what I did down here for some crazy reason? See how I went down to 2?
Barely even noticed.
No, it's okay. I mean, that's on me. It's not on you. All right. No, Jeff. All right. There's too many buttons to push here. Come here. All right. Okay, let me do this original thing correctly. So that should be right there. No, Jeff. Again, you did the same thing. Every now and again, I want to remind you guys that I am just a human. Okay. Let me see here. Here we go. What am I doing? That green? All right. So now I can take this point, lift it up 1. Take that point, lift it up 1. Choo-boo! And so now this is just gonna. So my midline is. How do I do this without really drawing it? So my midline is here, right? So now I'm gonna go. Wee-haw. Holy shit, John! Make that big. There we go. And it's just gonna keep kind of going like that. So pretty cool with that? That's not that bad, right? As long as, just like any transformation, as long as you know the base function, you have some anchor points and you know the shape. Transformations are simple. Okay. There's no special name for this because it just lifts the function up by 1, right? So whoop-de-doo. So here's the freakiest transformation for trig functions. Let's see. Let me give myself some room here. Ooh, I like it. Go away.
And these are all the same for cosine.
Yeah, exactly the same for cosine. Now, you'll realize that we haven't even graphed tangent yet, and I sort of decided not to do that yet so that we can just focus on these completely. And then we're going to come kind of like back up and do tangent. Tangent's going to look much different, much different. Real quick question, why would tangent look very different from either of these? What's the tangent of 90 degrees?
Undefined.
Undefined. So the graph, what will it have at pi over 2?
Nothing.
No, well,
Well,
I
an asymptote, sort of.
there you go. There you go. There will be an asymptote there. So technically, that was a correct answer. But yeah, there will be an asymptote there that will govern what the function does as it gets closer. I like it. So it's going to be slammed up there. It's going to be, it'll actually end up looking like a cubic function. So we'll see that when we get there. So let's do this. What's the one transformation I haven't really done? There's two actually. There's two transformations I haven't done yet. So let's do them one at a time here. So I have got this transformation. Let's see. Let's not get. Yeah, let's do this. I like it. All right. Right now, normally, what would that do? What is that for? Like a regular function. What would we call that?
Vertical or a horizontal shift, so like left or right.
Horizontal shift. I like it. And in this case, is it going to move left or right?
Left.
Left.
Left. I love it. For a trig function, we call this a phase shift, just to be all neat, right? And it actually kind of relates to physics. Physics uses a lot of trig functions, not surprisingly, but we just call it a phase shift. So we can talk about things being out of phase. It could be because they've been shifted by some amount from each other, right? So cosine and sine are shifted by 90 degrees away from each other, right? All right. So let's see, what's this going to look like? Let's see. So let's draw our normal thing. We've got, let's go 1 to -1, pi over 2, pi, 3 pi over 2, 2 pi. And then this time I'll go back a little bit, right? Because we're going to have to go back here. All right, so the normal one we do is 0, 0, 1, 0, -1, 0. And this time I can go ahead and go back. Let's go here. So I go, weehaw. No, Jeff, sorry. That should be dotted. This is my base function. I get all excited. All right. Woohoo! All right. I was thinking about Loch Ness Monster. I want to draw these. Now, I've got to shift this thing back. So every point, I'm going to shift it back pi over 2. So let's see, I'm going to start here for some reason. I'm going to shift that back pi over 2. Shift that back pi over 2, and it should not be very surprising
That this is now the cosine.
Holy shit. Right, shift that back pi over 2, shift that back pi over 2. Shift that back pi over 2. Okay. So let me see if you guys understand what kind of problem is going to make this thing. This isn't that difficult. This is not that difficult. Can anybody point out why pi over 2 made an easy shift?
Because it's in the same like language.
All right, I like it. My scale incorporates pi over 2 directly, right? So what if I would have shifted by pi over 16? Would that be a fun day?
No.
All right, so I'm going to try to develop with you. I don't know if this book does this or not. I always forget to look. Some neat ways to make that kind of problem easier to work with. Because does that make sense to everybody? If I would have put a pi over 16, this would have been nowhere near as easy, right? So there's got to be a way to kind of work that out a little more ahead of time to know what the graph is going to look like. All right, so let's see how much more I can do. Let me just do a little bit more and then I'll let us out of here because it's my fault with my bad Wi-Fi. Let's just do one more thing. I do have a handout that I think I'll make active after I discuss this. Get in there. So what I'm going to do, we're going to do a trig function with a few things happening at once and where things aren't so nice. Oh, there is one. I haven't done that one yet. Damn it. Well, all right, maybe we'll do less than I wanted to just now because I haven't done the last transformation yet. Can anyone tell me there is one transformation thing that we have not done yet? And it's not reflection because I don't care too much about reflection. There's one thing we haven't.
The one touching the X.
Oh, I like that. So something touching the poor little. We'll do a cosine this time just to build it up. All right. I'm going to stop talking about something touching the poor X. All right. So what is that? What does that do? What does that do when it's inside with the X?
Stretch or compressed.
Stretch or compress. I love it. Will this be officially a stretch or a compression?
Stretch.
No.
Compression then,
Yeah.
like it's
Yeah, it's gotta
because
be
it's
it.
with the X.
Yeah, if it's with the variable, it's the opposite of what it looks like. So right now it looks like 3 point something times X. So what that actually accomplishes is it divides all the inputs by pi. So let me ask you this. Can we get to this relatively easily? Normally, how long does it take for cosine or sine to get through their complete cycle?
2 pi.
Yeah, normally it goes to 2 pi. What did we just say that this is going to do to all of my inputs?
Make them pi less.
Be careful, that sounds like you're subtracting.
Divided by pi.
Yeah, divided by pi, right? It's going to make it like 1 pith. I like that. I don't know if you guys are with me. It's going to make it like 1 pith as long. Maybe I
It
should have.
doesn't sound real.
I know. But it's like 1/2, 1/3, 1/4, 1 pith.
All right, fair enough.
Would it be a 1 perd? I don't know. All right, so stay with me. So this is kind of cool. What is the period of cosine normally? Period, of course, is just the length on the x-axis that it takes to get through a cycle. What is that period?
2 pi.
2 pi. So the normal period, let me put that there. The normal period is 2 pi. I like it. The new period for this function, how do I always find the period of something that's been shifted like this? What I do is I take the period divided by whatever's being multiplied here. Doesn't that capture exactly what we just said? It's going to compress by a factor of 1 over pi, right? Are you guys at all with me? The more you were comfortable with transformations before, the easier this stuff will be. We're just able to, transformations just go with trig functions much cleaner than any other function, to be honest. That's why we give them these special names. So now what's the period going to be? The period's going to be 2. So now I'm going to go from 0 to 2. So let me ask you this. Stay with me now. Obviously, we're going to do more of this, and maybe next time you'll even be able to see me, and I can use like a real whiteboard. How many steps do I normally take to get through a cycle? How many kind of steps using my anchor points?
4.
4 steps. I love it. And normally each step is how big?
Well, it's like a half.
Half a pi, right?
Yeah.
All right. So now my steps are going to be 2 divided by 4. Every step's going to be 1/2. And some of you guys probably noticed that it's just dividing the pi away. So if my regular step size is pi over 2, this new step size is going to be 1/2. But in general, if I know what my period is, I could just divide that by 4 to see how big each step is going to be. Let me stop there for a minute. And again, we're going to do more of these, obviously. So this one is nice. This one's almost too nice to believe because all I have to do is set up my normal stuff, but just don't put a freaking pi on them. There you go, Jeff. See how I'm just not putting a pi on them because I divided the pi away. And then it's just normal old cosine. So this one turned out to be a nice one. So then it goes, wow, woohoo. So this is one that you actually don't have to show like the base function and the shift because the scale could completely change, right? Now my scale is not based on pi's at all. It's just based on, you know, normal little half steps. I have no idea how you guys feel out there right now. Are you all like
it?
All right, all right. Is everybody else kind of like, why couldn't his Wi-Fi just completely go out?
I mean, it makes sense.
Thank you for that. I guess everybody else is in the, come on, Wi-Fi, give up already. Can't. Okay.
I mean, but what else would I do with myself for this like hour and a half?
Yeah, there's nothing. I mean, there's nothing past pre-calculus. I appreciate that. Okay, so let me erase this. All right, so I want to do one example of this thing I was talking about, and then I will let you out. All right. Yeah, that's fine. All right, because I appreciate those of you who are actually out there, because I don't know, some of you guys might have just walked away. I don't know. I never know. All right, so what if I had this going on here? Let's go back to sine. All right, let's see if I can make it not too freaky. Can I do that? Well, no, let's do this. Sorry. Yeah, all right, we can do this. All right. So we got a couple things happening at the same time, right? Now, let me ask you this. Remember when we had that one earlier? What was it? It was this year, right? We did this one earlier, correct? All right. I can see Rio moving. I was sort of like asking you a question so I can make sure everybody was still with me. We did this one earlier. Yes, we did. Okay. Why was it so easy to tell how far it was going to move left to right?
Because our steps were in pi over 2.
All right, that's why it was easy to do, but it was easy to see because I see exactly what x is, how x is being affected. X has a pi over 2 being added to it. Now, up here, can you see exactly what is being subtracted from x? Right, I know what I'm going to use to figure out the period, correct? Just like we use this pi, I'm going to use this pi over 2 here, correct? That's going to help me figure out what the new period is, just like this one did. But can anyone see what is actually being subtracted from x? Because right now I know pi over 2 is being subtracted by pi over 2x.
Is it 1/2?
No? So here's what you can do. Take a pi over 2 out inside. And then what's left inside? Here, what's left?
X minus 1.
There you go. All right, so let's analyze this thing. Let me see. Let me erase this stuff down here. There we go. So let's do the period first. And that's all right, Jeff. We'll get there. What I haven't done for you yet is, so Jordan pointed this out earlier. In the book, they use A, B, C, D, like complete crazy people. So they do this in the book. You'll see this. A sine, let me see if I remember exactly. I think they just do this shit here. It's really
that exact thing.
The only thing that makes nice sense is the A, because A amplitude, that makes sense. But then B, C, D, what the shit? All right. Now I'm not saying what I'm going to do is necessarily better.
I like that you erased that area for space, and then you were like, hold on, let me just scribble.
I made myself space, so then I had to use it. But now we see what each of those letters mean. And I think to me, better than just A, B, C, D is they each get a letter. I don't know. That kind of makes more sense. Maybe it just makes more sense to me, but we'll see. So in general, if I have, so let me kind of show you what we're going to end up using. Yeah, we're going to have a K here. I don't know if that sounds familiar to anybody. Oh, let me see. Now I've gone and forgotten. Good job, Jeff. That's been a little while for me. But right now, all I care about is this. In general, to figure out the period of a trig function, you take its period, in this case it's sine, you take what it normally is, and you divide it by whatever the hell k is. It's exactly what we did over here. We discussed why it made sense, right? I want you guys to be semi with me.
You divided 2 pi by 4 before, but now you're saying to divide it by k.
No, I didn't divide it by 4. I did not. How did I figure out the new period?
Oh, yeah, okay. But the second part you divided by 4.
How big the steps were. That's all.
Okay.
How do I figure out the new period? I take whatever the normal period is for that trig function, and I divide it by k, which is the number that's here. I like it. So, what's the new period of this going to be? What's the period of sine normally?
2 pi.
Yes, 2 pi. And so I'm going to divide that by pi over 2 because that's what k is. So can somebody do 2 pi divided by pi over 2?
4.
4. Kick-ass. The pi's die. 2 divided by half is 2 times 2 is 4. So the period is 4. What's the phase shift? To the...
Pi over 2.
Stop.
Right. What? -1.
To the right 1. Yes? Yes? Nothing has changed about transformations. Nothing. We're giving some of them different names because of the specific function. But nothing has changed. Nothing can change. It's not allowed to freaking change. Transformations do the same thing no matter what the function is. What the function? So here's the last thing I'll show you.
If
But-
we see we have to factor out the pi over half in order to get
The phase shift.
okay.
Because, and I really want this to make sense, the way it's given to me, I can't see exactly what's happening to x. Now, I totally can.
So I have a question.
Yes.
If the value of the amplitude
Yeah?
and the how about like a 2 pi over 2x minus 2 pi over 4 or something.
Wait. So you're trying to give me like, so what do you say now? Sine of?
Like pi over 2x minus pi over 4. Like, what if it's different values?
You can still factor out a pi over 2, yes?
Oh, okay.
Who can tell me what would be here? You could do it. I hate that you can't see me, but I would take a pi out, right? So it's going to have a 1 on the top. And I would take a 2 out of the bottom. So what's left on the bottom now?
2.
There. Okay.
Then,
So I don't care what the shit I put here. You can always take this out. Always. Right? Okay. Go away. So here's the last thing. I keep trying to get to the last thing. Watch what I can do. So tell me this. So normally, let me see if you guys are cool with this. Sine, what do we normally go from to? We normally go from 0 to 2 pi for inputs, correct? Yes? Okay. What is inside All right, so this work we've done so far, kick ass, awesome. But I'm trying to now show you how I can a little extra something. What is inside the sine function right now is this, correct? From the beginning, yes? And normally I put a 0 in and then I put a 2 pi in, sort of like the beginning and the end. Does that make sense? So the beginning output is whatever sine of the inside being 0 is, and the last output is whatever putting 2 pi gives me. All right, let me stop there for a second. All right, I really want this to, now obviously we're gonna do more of this next time. So watch this. Let me take that out of the way for a second. So what I can do is I can take the inside and I can set it equal to 0. Ooh, now what does that do for me? Now watch. I really want this to make sense because I have to make the inside 0. That's how I normally start graphing my sine, is I start at 0 degrees. So what would make the inside 0? Well, we can solve this for x, can't we? If I divide by 2, I get x is 1. So now I'm not going to go from 0 to 2 pi. I'm going to go from 1 to what? So it's going to begin at 1. And where's it going to end? Well, where do I normally end? Where do I normally end?
2 pi.
2 pi. So now I can figure out, if I do all this, let me do this a couple different ways. Let me divide the pi away, make this nice normal numbers, multiply by 2, and then add 1. So I'm going to go from 1 to 5. Let me stop for a minute. I am almost certain that a chunk of you guys are completely lost because you did not speak up earlier. But right now, I'm trying to show you, this is kind of a nifty way. This is where things begin. This is where things end. And that will be very helpful when there's a lot, even more shit going on in my function. Why does this make sense? Well, what's the period of this new function? What's the period we figured out is 4? What's the period down here?
1 to 5.
4.
4. Yeah. And this is going to move to the right 1. Normally I start at 0. If I move that to the right 1, where do I start now?
Right at 1.
Right at freaking 1. All right, so let me, I'm going to stop sharing this. Is everybody ready? I lied. I'm going to show you one more thing because I'm evil and you should know that by now. Has everybody got this, enough of this down? You're all like, so much more than I wanted. Okay, I'm going to stop sharing. Now let me share this. Shit, where are you? Oh, dadgummit. So there's a handout up on Canvas. Well, that's interesting. Why am I a student? All right, maybe that's useful. Let me see. I don't think I have it active yet, so give me a second. Let me see. Unit, no. So let me activate this. Wonder Canvas powers activate. Here we go. So unit 8, here we go. Bam. Look at that very awesome title of this thing. That sounds very hopeful, right? How to graph trig functions. So what I've done here is I've basically, here's all the letters I'm going to use, right? I know I have A and B in there. I don't care. Amplitude is A. That makes sense. And it's the absolute value of A because A could be negative. That would just be a reflection. Is everybody cool with that? We haven't talked about tangent yet, but its period ends turns out to be pi. We'll talk about that later. But right now for sine and cosine, that's exactly what we did earlier. Phase shift, I've got to factor the K out so I can see what the hell's going on. And then here's where I do the begin and the end. All right, now as some of you guys get into this, you might not have to do this, but it's kind of nice to know I can always do this just as a check to make sure I begin and end at the right places, right? Now, obviously I sort of cheated. I had a computer do this for me, ha ha ha, because I'm the teacher, nah. But this is all the kind of work I would need to see from you, right? Now look at this bad boy. This has got a lot of shit going on, so we're not quite there yet, but all right, so that's up on Canvas now if you want to take a look. So hopefully that is helpful. Otherwise, I think that's enough. That is more than I thought I might be able to do with the way things started. All right, guys. So let me know if you want to, if you need anything afterwards, if you have questions. Otherwise, you are free to go. Enjoy your weekend.
I gotta stay.
Okay. Let me see if my Wi-Fi is back. Wouldn't that be funny if it's back now? That would be hilarious. All right, let's see.
Thank you.
Sure.
Later.
Oh crap, it's still bad. Let's see how many people are not really here.
Have a good night.
You too, Austin. I think Mason's probably not really here. Mason? Mason? Yeah, I'm gonna get him out of here. Go away. All right. What's up, Dave?
Okay, so it's a little personal.